Today we will cover some more, and I must, whenever I take a class, a few people, I always prepare for about an hour or so because I don't like to come to a class unprepared. But unfortunately, today I had such a busy day that really I could not spend much time in preparing. So it is possible that I may not have covered everything. I'm unable to find my pen. Just give me a second. Yes. Okay. So let us start. Let me just go over what we did in the last class. So basically, sorry, we are talking about file handling. We are talking about file handling, and there are a few things I did not mention. In Python, there is a concept called an iterable. Iterable, iteration, and iterator. I will not tell you the details, iteration and iterator. So basically, I'm not going to go into details of this, but you need to know that most of the data structures in Python are iterable. That means you can go over them one by one. If it's a string, also it is iterable. If it's a list, it is also iterable. If it is a tuple or a tuple, I don't know, it's also iterable. So is for set, so it for dictionary. These are all data structures which are iterable. But just like your data structures, even a file stream is iterable. Even your file stream is iterable. That means if you read the data into something, if you read the data into file object, or if you create a file object, then it is possible to go over it one by one. I gave you an example yesterday where we did the read function. The read function was, if you remember, let me just show you. We created a file object, right? So we created a file object, and then just one sec. I'm just coming there. Let me come from the book. That's a little better. So we created a file object, and then we were reading lines from the file using the read function. So the read function reads one line at a time. So once the read function has read one file, or I should not call it function, I should call it method, because it is the method of a class. It's a method of an object. So read the open function gives. Let me just remind you. What we did yesterday was we did f object is equal to open and then a file name. So once this was opened, we got a file object. Then we could do something like f object dot read, and this is equal to something, say, my line. So what this does is it reads the lines one by one of this file. So it is iterating over the file. If you call this function twice, the first time it will read the first line, the second time it will read the second line. If you call it the third time, it will read the third line. So it is reading the lines one by one. That is why the file stream is also called an iterable. I hope that is clear. Okay, so let us go ahead. Like like for example, I showed you this code. This is there was a file in my computer, this script which I had written when in my old computer. There was a folder called Python 3.4 which had a folder called my script, and which had a file called derosio.txt. Derosio, by the way, is a very famous very old poet. He wrote that famous poem, My Country in Thy Day of Glory Past, a beauteous halo circled round thy brow and worshipped as a deity thou wast. This poem I took as an example to tell about this. So when I did the first read with 10, it read my country. That means the first line. And then when I asked it to tell, it told me the tell. If you remember tell, the function tell gives you the current location of the cursor, the current location of the cursor. The current look. So therefore, once 10 bytes or 10 characters are read, then the cursor will point to 10. And when I again give the read, when I give the read the second time, it reads the next line. So the first line was my country, and in the second line was in thy day of glory past, beauteous halo circled round thy brow, and so on and so forth. The important thing to note is that this number, let me just clear it out. This number inside the read, this number. Now there are two possibilities. The number could be less than the number of characters in a particular line, or this thing could be more. If it is less, it will read less, but if it is more, it will read only up to the line. I will explain this. Maybe I'll try to give you an example, but you can do your own research. The point is that the read function returns a string. The read function, like you can see over here, when I read these 10 characters, this is on idle. So we are not using idle, but I wrote this part of my book in idle. I should have written it in Jupyter, but part is in idle, part is in Jupyter. So read 10 will give the first 10 characters with quotes around them. That means it is a string. It is a string. We will try to prove this also. So this we had discussed yesterday. Let us move ahead. Then I told you seek. I talked about the seek function. Now, see, seek is also a method of the file object. And as I told you, the file object is created by using f of j, or whatever name you want to give, is equal to open file name. So this file object has also got a method called seek. And the seek tends to set the this tends to set the current of the cursor. So let me just again say there are two methods of the file object: f object dot tell and f object dot seek. Both these methods are for the file cursor. That means where the cursor will point. F object dot tell will tell you where the cursor is, and f object dot seek is used to place the cursor wherever you want to place it. So we are talking about f object dot seek. That is a seek function. So when you talk about the seek function, it has got two parameters: offset and from what. This offset is this you have to give. This is have to give, and this is optional, and this is optional. That means it has got a default value. So right, it has to offset and from what. The offset parameter is mandatory. That means while the from what is optional. Offset parameter indicates the number of bytes by which the cursor is to be moved. So it indicates the number of bytes, and from what is the anchor. That means from where. So you move how much and from where, or the point from where the count of the offset begins. By default, it is 0, meaning that the offset is done from the start of the opened file. So therefore, let me just again try to explain this to you. Let me just try to explain this thing to you. Let me suppose you have a file with a number of say lines of code, lines of script in a text file, this like, and this is consisting of characters like that, characters. So your function is seek offset from where. So if this from where is 0 and its offset is 5, what will happen? It will start from the beginning of the file, and the cursor will come 1, 2, 3, 4, 5. It will come over here. So this offset will determine how much it will move, and this from where will determine the place from where it will start. So the first is 0. So 0 means that it will start from the beginning of the file. The second is 1. The 1 means wherever the cursor is, if the cursor was here, it will move, and you put 5,1, then it will move 5 bytes from its location. Wherever, suppose it is here, it will move 5 from a 1, 2, 3, 4, 5. And then the 2 is for end of the file. So this is the way it works. Let me just and then I told you also about the yesterday, these 3 values are also stored in the following constant of the OS module. os.seekset is equivalent to the value of from what, os.cur is equal to what 1, and osseek.end is equal to that of 2. I think we discussed this in the last class. Let me just stop for a second and ask you guys, am I understandable? Am I clear? Am I visible? Is my screen okay? Is everything fine? Are you able to follow what I'm saying? Someone say, then I'll.
Yes, sir.
Okay. So, all right. So we did this right. Now let us talk about the next 2 important methods of the open file object. One is called read line, and other is called read lines. So read line and read lines. Read line has one parameter size. If the size is absent, so there are, see, note, there is read line, read line, and read lines. Read lines. So this is reading the number of bytes. This will read the number of line. It'll read one line at a time, and read lines will read all the lines to the extent possible. But there are other differences. Let us talk about those differences also. Let us understand. So read line method has one optional parameter size. If the size is absent, the method returns one line of text in the form of a string. The new line at the end of the thing is also returned as the part of the string returned by the method. We look into this. If the optional size is present, then the parameter size indicates the number of bytes to be returned. When the end of the file is reached, read line will return an empty string. Note that since read line only is memory, the syntax is read. I've made a mistake. It should be read line. The method read lines returns all the lines until the end of the file is reached. Another important difference is that read lines method does not return a single string but a list of the strings. So each line is in the form of one string in the list. For example, if a file has 5 lines, then read lines will give a list of 5 strings. I'll just show you. I searched the net just before I took this class. I was just trying to find some good place. I found this one. No, not this one. Maybe this one. Yeah. So this is a good way of explaining things. So suppose this is a file containing these 5 lines, 1, 2, 3, 4, and 5. If I use the read line method, it will give me the first line, this is the line, but it will be in the form of a string. All right. And then if I use read line again, it will give the second line, then again it will be form of a string. Like that it will give, right? But suppose I use read lines. If I use read lines, then all these 5, 1, 2, 3, 4, 5, these 5 lines, they will all be read, but they will be in the form of a list. They will be in the form of a list. You can see this is the opening, this is the closing of the list, and every line will be one item in the list. Therefore, if this list is called, say, my L, then my L index 0 will be this line. My index 1 will be this line. My index 2 will be third line, like that, 4 and then 5. Is that clear? Is that clear to everyone? Anyone would like to? Yeah.
Yes.
Okay. So let us move ahead quickly.
सर इससे तो फिर ये होगा ना कि हम जब भी फाइल ट्रांसफर करेंगे तो हमें कॉमा सेपरेटेड लाइन मिल जाएगी.
Come again, please. Sorry, I couldn't get you what you're saying.
Yeah.
Just speak a bit slowly. Yeah.
हाँ सर, जब भी हम रिट्रीव करेंगे फाइल्स का डेटा तो हमें कॉमा सेपरेटेड आउटपुट मिलेगी.
Comma separated output is not the correct way to do. हमें एक list मिलेगी.
Yeah, which is comma separated. Huh?
Obviously, in a list, if the list, the all the items in the list are separated by commas, तो हमें एक लिस्ट मिलेगी और वो लिस्ट का एक प्रॉपर लिस्ट होगी जिसमें हर कॉमा सेपरेटेड आइटम विल हैव अ इंडेक्स. Like this is the line, like here, this this is line 1. This will have an index of 0. This will have an index of 1. This will have an index of 2. This will have an index of 3, and then like 4, like that.
Yeah,
It's a proper list. It's a proper list, and every line is converted into a string. So this will be covered in quotes. I'll show it to you. Let's do it. Let's do this, right? Okay. So let me come back. Let's do a bit of theory, then we'll come back. All right. This is something which doesn't really require my intervention, because this is something which you can and should be able to study on your own. Anyway, I want to talk about another thing. Let me go to that thing first. In fact, we tried to discuss in the chapter on I think exceptions also, right? Let me come to Let's talk about this. Using the with statement to close the file automatically. Just pay attention, because this is something which is used very, very often in the code, and this is the correct way of opening a file. Python provides a method whereby you ensure that files are automatically closed after opening. You see, otherwise, if you use the same old technique that f object is equal to open file name, then this f object will not be closed on its own. You have to close it explicitly. That means you have to write f object dot close. So when you do this line of code, then this file object will be. See, basically, you need to understand how the things work. Let me just try and show it to you. So basically, think of it like this. So suppose this is your hard disk, let's call it HD, and this is your RAM. All right, RAM. So what you have done, you use f object or whatever is equal to open. Let's call, there's a file existing over here. Let's call it f file 1. So when I do open file 1, what will happen is that the data of this file will come into the RAM, and this data will be pointed to by this f object, right? So as long as there is a variable name which is pointing to that particular data, the garbage collector of Python cannot delete this file. They cannot delete this data, right? But suppose you are doing f object, then is equal to 10. That means you have reassigned the f object to a integer. So now there is nothing pointing to this memory in RAM. There's nothing pointing to it. So the garbage collector, which keeps a count of all your variables, understands that this memory is now gone, useless. It will remove it. That is the way a typical garbage collector works. Now, just to make it a bit more complicated, suppose you are done f object 2 is equal to this. I discussed f object, and then you had put f object is equal to 10. Suppose you had done this, then also this memory will not be removed, because even though f object has gone, f object 2 is still pointing to this memory. So the garbage collector knows that there is an alias for the f object, which is called f object 2, which is still pointing to the memory. That is why it is not able to the term used is it is not able to reclaim the memory, or it is not able to get back that memory which is no longer in use. This is the way a typical garbage collector works in Python. However, there's a problem here. Suppose I do f object is equal to open some file, right? And then just after this, my program crashes, right? So then what happened? The data from the hard disk which has gone to the RAM, that is there in the RAM, but since the program has crashed, the Python interpreter is unable to reclaim it. Therefore, I would like to work in a way so that, God forbid, should my program crash, And you see, as I told you, opening files are very sensitive, you know, steps, because they often lead to problems. The file names may not exist. There should be wrong path name. Something file permissions are not there. Something maybe their hard disk cannot be accessed. Hard disk is corrupted. Memory is overloaded. Memory is overflowing. There's shortage of memory. There can be so many things. So should that happen, then I need to write my program in such a way. I need to write my program in such a way that, God forbid, if the program crashes, then the memory should not. This is called leakage, memory leakage. The memory leakage should not happen. Memory leakage should not happen. And that can only happen if the garbage collector, even if it doesn't function, I am able to reclaim that memory. Now, coming back to my book again, is that clear? What I'm saying, does it make sense to all of you guys, or am I talking about something which you guys feel is not the right, or you're not able to follow? Just somebody respond quickly so that we can move forward.
Yes, sir.
Okay. Okay. So this is clear to you guys. All right. So what do you do? So I'm saying that in case the program does not explicitly close an open file using close function, then the garbage collector will eventually close it, but this might take some time, right? You see, you might think that what's the problem here? You are right. If you're a single guy working on a single computer, writing some small, let's call it toy scripts. The word uses, if you're using some toy script, like my book is full of toy scripts, not scripts which are not a program or toy programs which are used in real life, but which are used just to show you something. That is fine. But if you are running a server, maybe with hundreds and thousands of users connecting to you, then every bit of resource is important. So you might have something crashing and using up your memory. So that is the problem. Till such time that the garbage collector does close the open file will continue to reside in RAM and utilize resources. So one should always explicitly close an unopened file using close explicitly. What I'm saying is here is that if I do f object is equal to open a file, then this file will remain in the memory. But suppose whenever this f object, this variable is removed or deleted or assigned to something, then at that point of time the memory will be reclaimed by the garbage collector. It is not that the memory is lost forever, but there may be a time gap between the use of the memory by the program and the ultimate reclaim of the memory by the garbage collector. Therefore, any good programmer, when you open a file, you should always close it explicitly. After you have done with whatever you want to do, you want to add something to the file, you want to delete something, you want to copy the file, whatever you want to do, after you have done with it, you should close the file explicitly. That is the way it should. However, there may be another problem. Consider the following scenario. You open a file, however, before you close the file, the script crashes due to some bug. Then you will not get a chance to explicitly close the file being this thing. So the Python has designed two ways of doing it. What are they? The first method and the second method. First is enclose the file opening code in a try finally block so that in case of an exception, you can close the opened file. This is, you need to understand. I'll explain to you. I'll explain this to you. If you remember, we had talked about a try except finally. Shall I? So if you remember, let me show you in the book. Let me just, it will take a second, but it is worth it. I'm on page, I'll remember the page. I'm on page number 3077. Let me come to exceptions. Let me come here. So this is important because it's important to link the various parts of the program. So one sec, this thing is harassing me. Let me just put down this telling you what's happening. Yeah. So if you remember, I had shown you this. Yeah. If you remember, I had shown you this diagram. So suppose I put, instead of this suspicious code, I have a f object is equal to open some file. And there is an error. And I'm able to, I don't know, my program might be able to deal with the error, yes, or may not be able to deal with the error, no. In either case, I will be entering the finally block. So this block of code will give me an opportunity. So what I will do in this block, I will write close f object. So what will happen is that before my program finally either crashes or doesn't crash, I get a chance to close my file. So therefore, one way of preventing the memory leakage, or one way of preventing that, if God forbid, if the program or the script crashes during the file opening or immediately after the file opening, but before the file closing, if you have enclosed that part of opening file in a try except finally block, then you can put a close function or a close method in the finally block to make sure that the sorry, this shouldn't like, this should be f object. I'm so sorry, f object dot close. It should be like this. I'm so sorry, I gave the wrong this thing. So you are able to close your opened file before the program crashes. Is this clear? Does it make sense? Yeah. Anyone? If you have, this is
Yes.
important. If somebody has a question, please ask me now. I would love to answer your questions in case you have any. So coming back to we got lost to another area, but I thought it is important that I should tell you this. Okay, so we were here. So there are two possible solutions for this. First is enclose the file opening in a try finally block, so that in case of an exception, you can close the opened file. This method was followed in Python 2.x, and you can also be done in Python 3.x. But in Python 3.x, there is another more elegant solution. When I use the word elegant, I mean it is better programmatically, L-E-L-E-G-A, elegant. So there is a more elegant solution to do this using the with statement for opening and automatically closing the file. Let me show you how it works. So it works like this. So it is like this. Here is the path to the file. This is the file. I've given the absolute path with, this is the keyword, open, path, the mode as f of j, and then do something and this thing. So in this block, this is the block. There are in fact two blocks. There is a with block, with open path, then something as, then this is the second keyword as. So there are two keywords. Let me just show this to you again. So there are two keywords. This is a keyword and this is a keyword with something, with open this thing as f object. So this is the function or the method. Open has to be given two variables. You can skip out on this. If you don't mention anything over here, then it is automatically, it has a default value of r. But if you want it read and write, so we have put r plus. So what will happen is open. So this has created an iterable. This is created an f object. For line in f object, print, and line in f object is every line in f object. So with line this thing, print line. So let us see this code. Let us see this code in practice. I think I put it somewhere in my script. Actually, there's a lot of so much of code. Just one sec. Give me a second. I put it somewhere. I don't want to write the whole thing. It will take a lot of time. Yeah, it is here. So just let me show you the code. So it is the exact same code as given in my book, right? So I have done for this thing, this is the path here with open path r plus as f object. for line in object, print this. Let's do it. Let's run this. Let's see what happens. So it has got some, because I did some overwriting. Let me just, let me do one thing. Let me open preamble 2. Let me open preamble 2 and let me see what is there in preamble 2. So preamble 2 is not shown here. Let me just open it. So preamble 2. This is preamble 2. Let me open it. Let me open it with Notepad. So it has some funny data in it. Let me just delete this data. Let me just pick out something from somewhere. Let me do this. Let me copy it. Let me put it in preamble 2. Let me save this. And now let me run this again. Now let me run this again. So let me run this again. So let me run this again. Yeah. So you can now, for those, I can just, this, let me just show the code to you. So this is a very important, very, very important step in programming. And with open, this is something you will always find in most programming, this thing. So with is the first keyword, then this thing. As if this is this variable name, you can choose. Since it's a file object, you should use f object, or you can use f handle, or you can use f underscore object. But whatever you do, you should be consistent. Like I've used f capital O object. So I've used something like a, this camel case kind of a thing. So if you're using camel case, use camel case throughout. If you're using underscore, use that. So for line in f, so what is happening? Now we are iterating over f object. So as I told you, f object is a file-like object, is basically a file stream. So for line in this thing, I'm printing this, right? Now this asterisk actually is superfluous. I could have removed. Let me remove it. Let me run it again. So that asterisk which was there is gone. So now it is printing every line. So as I showed you in that this thing, I had put this is the first line, this is the second line, this is the third line. I am printing each line one by one. Is it clear? Anyone?
Yes, sir.
Yes, sir.
So if I put a this thing, if I put a let me ask you, if I put a statement print type of line, what do you think I will get? Anyone? Let's do it. String, yeah, as I showed you, because this line is coming from the read method. So therefore it is a string, right? It is giving string. Each one is a string. It's iterating over the each of the lines of the code. Okay. All right. Is it okay? Let's move ahead. Okay. So we have finished, did we do right? No, we didn't do right. Let's do some right.
Sir, just one thing, sir. So if we write instead of line, if we write lines,
If we write lines, no, then it will read everything in one go.
and that will be that will not show as string.
No, it will show as a list.
Right, sir. Got it. Thank you.
But here, here if you show lines over here, it will still be a string. No, see this. What you can use X over. You can use anything. Let me use X over here. What this I understand. Is that what you're saying? If I use X also here, no. I think you have not understood. Let me do X. It will still work. This X is a local variable. Now I think you have this thing. This is for X in. This is a for loop, and X is a temporary variable which is created on the fly at that point of time to iterate over everything inside the F object.
Got it, sir. Got it. Got it. Thank you, sir.
It is, yeah, it is. Line is maybe a confusing this thing. I use line because here the F object, when you're iterating, it'll give you lines. But suppose if F object was a list, then I could use something like each list item. If it was a string, I could use each character. So I should use something which makes sense. That is why I use line. Is it clear? Yeah. Okay.
Yes, sir.
All right. Let's move ahead. So we right. Let's talk about writing. Oh, wait. So to write, there are two possible methods, append mode and the write mode. It adds data to the end of the file. It simply overwrites the file. In both the modes, if a file by given name does not exist from before, it is automatically created. Note that in write mode, the existing text is overwritten, and append mode, new text is created. Also note that the method for both writing and appending is write, but the modes are different. So if you want to, suppose you want to write to a file and you have this F object and you want to do dot write, then you will get file name followed by W. And if you want to append, you will again use write only. There's no method called append. It's again write, but it's file name. And instead of W, you will have an A. There's the only difference. So for both writing and appending, the method is write, but the attribute, the second attribute for the two is different. For write, it will be W. For append, it will be A. Is that clear? Yeah. Okay. I presume it is clear to you guys. Okay. Write lines. Yeah. So there's a method called write lines. Write lines writes a sequence of strings to an open file. The sequence can be an iterable object like a list of strings. So let me show you an example. Let me just show you this with an example. So I know you can do your own research for these things because I cannot tell you everything. All right. Yeah, this is a function. Let me just run it. So let me just this thing. So I had a list called myl. There are, by the way, there are certain programming, do's and don'ts. One of them is that you should never use small l in your variable names because you can confuse it with one. So you should use capital L. Similarly, you should never use, if possible, zero because you can confuse it with O. So if you use open, fine. But if you use OX, then we don't know whether it's 0x or ox. So this is just a side. So my L is consisting of one item, two items, three items, four items, five items. So it is an iterable. It is a list of strings. It is a list of strings. And then my path is equal to R. I've explained to you already. This is the path where I'm going to write. So if this file did not exist, now let me just, if this file did not exist, it will be created. Then with open, my path this thing, write lines. So I am writing the lines and then I'm reading in them again. So there are two with functions. The first one writes to the thing and see. And just let me do this again. And you notice one thing. That after this, the file is automatically closed. The file is automatically closed because this format of with as open as F, it is closed after this block is executed. And then I again read it. Then I read it and it is like this. So does that make sense? Is it clear?
Yes.
Yeah, now you just notice one thing, that there is no space between quick and brown. यहाँ पे कोई space नहीं है. So that is because if I put a space here, now I run it, it will give you quick brown. That is because it will simply append the items, and the white spaces, if they are there, they will come. If they are not there, they will be all put together. So this is about write lines, and I hope this also is clear to you guys. So we can just move ahead to the next topic. some more advanced, this with I've already discussed. So Python IOStream I've already discussed. Code for deleting a particular line number in a file. So I'm going to, this will help you to learn programming better. In the following script, there's a function fdel line, which takes two parameters. The first parameter is the file name. No, so now we are basically done with opening and closing of files. I'm giving you a problem and I'm giving you a solution. The problem is that given a file name and given a line number, delete that particular line number from that file. Suppose a file has, so I have to give it, so I've created a function called fdel line, and it is given two parameters, parameter 1 and parameter 2. The first parameter is the file name, and the second parameter is the line number to be deleted. This function I'm writing, and I'm trying to explain the code of this function to you guys. The code is given in my book, but let me just try to explain it for you. So what I have done is, I've created, in my book, I've created a file which has got these three lines. And these three lines are stored in a file. I'll show you. But let us just go over this. Unfortunately, this code is split over 2 pages. Let me, so therefore, open the HTML and let me come from there, right? So let me come. Yeah. So this is the code. I hope it is visible to you guys. So I've written a function called dline, delete line. It is taking two parameters. My file is the first parameter, first, and line number is the second parameter. Okay. So what I'm doing is, I am now, there are two with blocks. This is the first one, and this is the second one, right? So let me just show you how this thing works. So right. This is the first block. The first block is, you can read it. The mode is R plus. The mode is R plus. Let me just, give me a second. I'm coming. Just give me a second, please. Yes. So the mode is R plus. The mode is very clear, R plus as F1. Note that F1 is a local variable which has been created on the fly for this width block, and it is now F1 is basically the file object. F1 is the file object. It is a file object, or file-like, or it's called file-like object. File-like object, right? And now I am doing F1 dot read lines. I'm reading all the lines. So I'm reading all the lines of the object into my L, and my L will be a list. My L is a list which contains all the lines of read lines. We'll run this program. Don't get worried. If line number is greater than length of my length, this is simply a test. Suppose the number of lines in my program are 4, and therefore the list will have 4 items. Let me just show this again to you guys so that you can understand. It's very important to understand. So what is len my L? This len is again a function of, it's a built-in function of the Python core Python, which will give you the length of this. The length here means the number of items in this list. So if the file had got 4 lines, there would be 4 separate items in the list, and this will give you a value of 4. Now, if I'm asking you to delete line number 5, then it should not work. Therefore, I've written if line number is bigger than length of my L, print cannot delete since line is bigger than my line number. So this will come. So this is an exception which will happen. And this is a if statement which will happen if you're giving the line number greater than the number of lines in the program. But suppose that is not the case. But suppose that the number of lines in the file is the line number given is less than the number of lines in the file, then you will come to the else block. Then I'm saying d line is equal to ml dot pop line number -1. This is very important. You know why I've written line number -1? You need to understand. Pop, you see, I skipped over all the chapters of string, lists, and all that. But if you do, you can pop the items of a list one by one. So basically, if you use a stack, I don't know if you guys have done the concept of stack. I can discuss it. We will discuss it.
Yes, I know.
Yeah, okay. Some of you may know, some of you may not know. It's not important for your work, but it is basically, you can think of it like that. There's a stack and a queue. Let me just tell you in a minute, you should know. Stack is what is called philo, and this is called FIFO. Philo means first till last out. Think of it like a stack of plates. You put plates on, this is plate number 1, then 2, then 3, then 4, then 5. Now you want to remove the plate. You can't remove the bottom plate. You can only remove the top plate. So what is gone in first will come out last. So first in, last out. That is a stack. So stack, you can think of stack of plates. And queue, on the other hand, is a queue. Suppose there are queue of boys taking a ticket. So whoever is first will get the first, then the second, then the third, then the fourth, then the fifth, then the sixth. So a stack is a philo or a LIFO, last in, first out. You can also call it LIFO, last in, first out. But for a list, it means the last item, the item to pop, and the number inside this will be popped. So therefore, if I give the line number of 4, let me just again explain this, because there is a problem of index which you need to take care of. Suppose a file has got 5 lines. Then the length of the list containing this, then the length of the list containing read lines will also be 5. But the index will be from 0 to 4. If a file has 5 lines and I use the read lines method and I put that read lines method in a list called myl, then the length of this list is 5, no problem. But the index of the items in this list are from 0 to 4, because the list index always starts from 0 in Python. This we have already discussed. So if I'm asking, and the line number here which I'm asking to delete is the line number starting from 1. So therefore, if I am asking you to delete the item line number 4, it means to delete the item which has the index of 4 minus 1, which is equal to 3. That is why just let me just show this. That is why in the else this thing I'm saying pop line number -1, because the index of the line number will be 1 less than the line number, and I will put print deleted line, d line. And now I'm checking. Then what I'm doing is what I'm doing. See, I have created this this my line, but that particular line has been deleted, and that will be written now myl. Now myl, just see myl. That particular line has been popped out. The rest of the lines are still there in myl, and I write back myl into F2. Right. So F2 will now contain whatever the lines in the original F1 this original file MF, but without that particular deleted line. Just let me show it to you again. Let me just. So I could have used F1 here also. So in this here, all the lines are going into myl. and then I'm popping a particular line and I'm storing, and therefore when I'm popping, then my L contains all the other lines except that particular line which has been popped. Then I'm again opening my F as F2 and I'm writing back my L in F in F2 in my in the in this thing in my file my F, but minus the particular line which has been popped. I don't know whether I've been able to explain this to you guys properly, but I'm sure that if you read the code, basically what I'm doing is I'm opening the file. I'm opening the file using read lines and putting that data into a list. Then from this list, I am removing that particular line, and that list with that line removed, I'm putting it back into the file to which I had read it from. I'm putting it back. Putting it back. Any questions so far? Anyone?
Sir, as I have understood,
Yeah.
since we cannot delete anything from middle, that is why we are writing again on the file.
Yeah. I am not aware of, see, there might be some Python libraries which people have created to do that, but you can't do it with any of the functions in the inbuilt library which I am aware of. So there could be people could have some, because Python has got hundreds and thousands of libraries. You can import that library and give because if you read, there are hundreds of files or modules for file operations. So there could be some module which does that you can delete a particular line number, but I am not aware of it. This is the way I know of how to delete a particular line number in a file. What you do is take the file, take its entire input into a list using read lines, then remove that particular item in the list, and then put the entire list back into the file by using write lines. This is how I have written this program. And
Right.
The important thing is not the important thing is to understand the flow of the important thing is to understand the flow of this program, because if you understand this flow, then you are good. Then you can write your own scripts and you can use the lab. Using libraries is nothing great, in my opinion. Of course, you should know how the library works and you have to read the documentation of the file. But if you don't know these basic things about how to open the file, how to close the file, how to use the if loops, how to use the else loops, how to use the pop, how to use lists, then how to use write lines. If you don't know these basic things, then you really can't do very meaningful, useful things in the programming, right? So let's move ahead, because already it is 8:30. We are good for 1 hour. We have another half an hour. And today also, unfortunately, I have some other work. So I may not be able to go beyond 9 o'clock. So, okay. Now let us talk about another. See, I told you that the core part is only very simple. It is only open, read line, read lines, write lines. So basically these 5-6 functions are all there is in opening and closing of a file. We have not done pickling, we'll do that. But let us come to another code for creating the copy of a file. So I have opened the source file for reading from it, open a new file for writing purpose, read data from the first file, can be string at a time or a complete data of the, so you can read one at a time or the entire this thing, write the data to the new file, close both the files. So the function is like this. I have written up. Now let me just again show you. So this is a very simple function which I've written in my book. The name of the function is fcopy. This is the name of the file, the original file. This is the name of the fcopy. So you have to, when you are calling this function, you have to give it two paths: the path of the original file and the path of the file to where you want to copy to copy the file, right? And with open, see, both these files must exist from before, because you are opening the file. You cannot open a non-existent file. You can write to a non-existent file, but you cannot open to a non-existent file, right? So open f origin r plus as f1. then minus f1 dot read. Reads the entire this thing. You know that it read the entire content. It is not read line, it is not read lines, it is read. Then with this thing, write. This is the call. This is the function call. Let me just show you again. So this is the again the basic thing. This is the function definition, and this is the function call. F copy. Is it clear? Anybody would like to ask? I'll show the script how it runs, but before I do that, anybody would like to ask me any question? Please go ahead. Yeah.
So we have to mention the file name in the function definition parameter itself.
Both the file names, the origin and the destination. If you don't do, yeah, this is the code. I'll show it to you. So let me run this. So I can show you. Let me open this preamble 3 and preamble 2 and prove to you that both of them contain this same item. Let me see. No, let me first discuss the code with you. So this is the function definition. And this is the source path, destination path. I could have put this entire path as the first parameter also, but this is not the way I like to do. I like to use a variable name and then put the variable name here and then another variable name, put that here. So these are the two variable names for the source and for the destination. And this is the call. So what it will do is this function call will do this entire thing. But since you notice there are no print commands inside, so it will do it silently. That means it will do it and you will not even know. You will presume it is done. Now, in this part, I am checking whether it is done or not. So what I'm doing, I'm opening this destination file, the file where I've copied. Then I'm using read lines. That means I'm reading out the entire data of the file to which I've copied. That is this preamble 3. And I'm reading right, and I'm printing the list of the lines, which is coming as a single line because it has got only one line. Let me just maybe add something to. So what I will do is I will add something to this file, the source file, and then when I print the destination file, I should get that same data. Let me see whether I succeed or not. So I will open preamble 2, right? So let me open preamble 2. Yeah, this is there. No. I didn't save this. Let me save this. Preamble2.txt. Let me run it again. Yeah. So you can see that now if you in case I didn't show it to you, the preamble 2 now contains so suppose I add let me add something here. Let me add something. I'm just adding and I do a control S. I'm saving it. Now let me run it again. Now let me run this again. So you can see that these the SSS which I added just like that with a \n, HHA, JJJ. These are the things I just added. They have all got added in it. That means my program is working fine. Anybody, any questions on this? Then we can move ahead. Anyone? I'm not getting any questions. So I think either I'm
Sir, understood, sir.
Either everybody is totally following what I'm saying or nobody's following what I'm saying. I don't know which one it is. So it is a list. And it's a list, and these are all items separated by commas. I can, I could have done something like this. I can do something like this also. I can do it has more than 10 items, so I will not be running out. I can do this. Surprising, it's a blank. So maybe 11 will be good. Yeah. So this is what I've done here. I've printed a particular index of that list just to show you that it is a list, right? Is it okay? Yeah. So let's move ahead. Okay. Program code for deleting lines having a word passed as argument. So this is another, see, the main part of the chapter is already done. I'm just showing you some sample scripts in my book just to make you guys familiar with the coding process. So what I've done over here, I'm saying program code for deleting the lines having a particular word. So what I've done, I've got a text file which has got these words: caterpillar, dog, catapult, lion, Catholic, tiger, catalyst, mouse. So this file I'm saying passed as an argument, area which consists of a function which takes 3 parameters. The first parameter is the source file name, that is file to be read. The second parameter is the destination file name, that is file to which the lines are to be written. And the third parameter is a string which, if present in the line, will cause that line not to be written in the destination file. So basically what I'm saying that I have certain lines in file number 1, in file 1, and then I will put them in file 2. But I will put only those lines in file 2 which do not contain a particular string. So I have chosen here, just for your example, I've chosen the string cat. So any word which contains cat will not go into the other file. Therefore, caterpillar will not go because it starts with a cat. Dog will go, catapult will not go, lion will go, Catholic will not go, starts with a cat, tiger will go, catalyst will not go because starts with a cat, mouse will go. This is the way the script is planned out. Let me show you it's a very small script. So what I'm doing, this is the function definition as before, and this is the function call with 3 parameters. This is the first parameter, this is the second parameter, and this is the third parameter. The first parameter is the source file. The second parameter is the destination file. And the third parameter is that string which is tested in the source file to remove those lines which contain that particular string. So this is the way it works. So this is my del word. This is my method. It has three attributes. F1, not attributes. It has three parameters and my word. F1 open. So we open this in read mode. Notice I'm opening the source file in read mode, read plus, and opening the destination file in A mode. That means it is being opened in the append mode, right?
इसको write mode में भी खोल सकते थे?
Yeah, it could be in write mode. Then, but every time you write, it will rewrite this thing. If you then you use if you open it in write mode, I think then every time you open it, it will rewrite the contents.
Content again.
Yeah. So it is better to open it in the append. I think it could work in write mode also because you're opening it only once. But it is better to open in the append mode, right? I'm not sure that you check it out. This question didn't strike me that why I didn't put in the W mode. So because you see, programming is like it's like a painting or a drawing. Everybody will have his own perspective. So you try out these things and you can find on your own. But the point is that you should understand how this thing works. So now there are two. So the first file is open. The second file is also open. Notice here I'm not using with. I should. Then for line in F1, that means I'm iterating over the first file like object. If my word not in line, my word is this thing. If it is not in line, agar wo line mein nahi hai, then that line is written to F2. See the write method will write and it will not overwrite because the file is open in the append mode. Had it been opened in the write mode, as you are saying, then every time the write function is there, it will rewrite that means every line will be written one by one and it will not be able to write. So it will not work in write mode. Print line.
इसको फिर R plus भी कर सकते हैं क्योंकि अगर read नहीं कर पाएगा तो write तो कर ही सकता है.
Yeah, I'm not sure I am whether you can append in the R plus mode. I've not done that deep kind of study, but maybe you can try it on your own, right? You guys try it out. I
Okay,
have
sir.
not, since I've not tried it, I really can't say because if I say something and it comes out something else, then only I will be proved wrong. So better to leave it to you guys to try it out. The important thing is let us do this. Yeah, let us do this. So let me first see so let me just show you the code. The code I've already discussed. The source file is cat.txt, txt, and the thing is no cat.txt. Let me see if we have a cat.txt or not cat, no cat.txt. So yeah, we have a cat.txt. It does have, let me just show you guys. So this is my cat.txt, and it has got a cat, caterpillar, dog, catapult, lion, Catholic, tiger, catalyst, mouse. Let me just add some more. Let me just add some few things more. Let me add cats. Cats like. This should be removed. Then I should have lion like. Then I have a mouse like. Sorry. Then I have a mouse. Mouse like. Just I'm adding mouse like. Then I have cat eyes. Tiger eyes. I don't know. I'm just adding something on the spot. And let me just save this. Now let me run it. I've saved it. This thing is always interrupting me. Now let me run this. So let me see the output. So I'm getting tiger eyes, mouse like. So you can see that it has worked, right? And now let me check out this also. No cat.txt. Let me see if it is something has come out there. So let me just see. No cat. No cat is not there. Just give me a second. No cat. Yeah. So you can see that the script is working perfectly fine. All the items with cat in the string have been removed. All other items are there. Dog is there, lion is there, tiger, mouse, dog, lion, tiger, whatever. Mouse, dog. Oh, it has come a number of times. I think there's a problem. So maybe it is repeated a number of times. I don't know. Like, you need to check out. Maybe the script is not working fine. Something may be wrong. Yeah. Okay. Maybe this. Oh yeah. This should be for line F1. This thing. If thing. Okay. So is that clear to everyone? So there could be a problem in this script. I leave it to you guys as a bug. Sort it out on your own and do let me know if you're able to find the answer. Okay. Let us come to the next one. But before I move, have I been able to explain the concept of file writing and file object, file stream, opening the file using with in a safe way? Have I been able to explain all these concepts to you? Just give me a yes or a no, and then we can move ahead.
Yes, sir.
Yes, sir. Yes, sir. Very much understood.
Okay. Now, there's a concept called pickling and unpickling. Pickling is also called serializing for persistence. What does persistence means? If it is in RAM, it is transient. The opposite of persistent is transient. Transient. So transient means temporary. Persistence means permanent. So if you are saving the program or the data into a hard disk, that is called serializing. All right. In some texts, it is also called marshalling. So pickling, serializing, persistence, and marshalling all point to the same thing. Sandhya, can I just call you in half an hour? Okay. I just call you. I'm in another.
Yes, sir.
Okay. I'll just call you in 15 minutes. Okay.
Sir.
Okay. So that is the way it works. pickling is not to be confused with compression. So file compression is not pickling. Following issues are witnessed while storing a Python object on the hard disk. During pickling, the Python interpreter while storing it needs to convert the object into a byte stream, which can then be stored in memory. I'll explain what it means. During unpickling, the Python interpreter needs to reverse the pickling and read the byte stream from the memory and reconstruct the object from this byte stream, right? Okay, so let me go further. What does converting an object hierarchy to a byte stream mean? In Python, everything is an object, and therefore it is representative of some class. Objects in Python have attributes and methods, and their attributes have values. So when a Python object is to be stored in a file, it has to first convert it into a stream of bytes. The pickled byte stream, which is stored on the hard disk, is used by the interpreter to reconstruct the original object hierarchy by unpickling the stream. This process is somewhat is object serialization in other programming languages like Java, though the protocols followed is different. So what has been pickled in Python cannot be unpickled in Java. This might seem a bit like Greek to you guys, but the concept is actually quite simple. Let me just try and explain by taking an analogy. Now, suppose you have an object. Suppose you have a class, say, let me call it C1, and then it has got certain variables, and those variables have got. Just one sec, my battery is going. Just give me a sec. Yeah. So, as I said, suppose there's a class, you create an object, that object has got variables, that variables have values. So when you are storing that into a hard disk, then you have to convert that object into a stream of bytes and then store them in successive locations, successive cells. So suppose it has got 5 variables, then you need to maybe store the name of the variable, the value of the variable somewhere, then the name of somewhere else. So this entire process is called pickling. And this is done in a non-human readable format. That means if you try to read this data without unpickling, you will only find garbage. Because what has been pickled using the Python program can only be read back or unpickled using the Python program. This is the way pickling works. So it is like this, that you are trying to, maybe I can't explain. Maybe if you had a suppose you had a one long stick, right? And you break it up into small pieces. And you number them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you put number 1 in the first block, number 2 in the second block, number 3 in the third block, number 4. So that's okay. But now suppose you didn't have a stick, but maybe you had a plant. There's a stick like this. This is the way I see it. It has got a branch like this, and it has got another branch like this, and maybe another branch like this, and then another branch like this. Then now, how do you number it? So the person who's storing this data, he needs to create some kind of a protocol that whatever comes to the left will be taken first, then to the right, then to the left. The numbering system, it will depend from object. So object is something like a plant, whereas simple stream of data is something like a stick. So now once you have stored, broken it up into pieces and put it in your memory, now to reconstruct this original plant, you need to know the exact same way in which it was cut and put into your memory. And then once you know that technique or that algorithm, then you can reconstruct the original from the memory. Am I able to explain the concept of pickling? I don't know. Does it make sense? Anyone?
Is it the concept of branch or binary tree?
Sorry, branch or?
Binary tree concept.
No. I just gave an example.
Okay.
This is an example. You see, I'm comparing the storage of a simple stick to the storage of a plant which has got multiple shoots. I'm saying that this is easy to do, but this is also easy to do, but you need to develop a protocol to do. You may decide that I will follow this entire branch right to the thing, then I will go to this and pick it this thing. I don't know the protocol of Python. I'm just giving an example that
Okay, sir.
something like this, if it was to be put into boxes, then you have to decide, and you send that box to somebody and ask that person to reconstruct it. Then you need to tell that guy how exactly you have packed and numbered these boxes. So it will differ. In Python, you may have a different scheme of things. In Java, you may have a different scheme of things. In some other language, you may have a different scheme of things. So what you have pickled in Python, you will not be able to unpickle in Java. That's the point I'm making.
Yeah, just like a memory mapping, it indexed.
It's something like encryption, decryption. Somewhat like that, sir. कि जब
It
तक
is
की नहीं
some
होगी
kinds. The
किसी के
point is
पास
that it's a protocol. It's not encryption. It's a protocol. It's a pre-decided. All the Python interpreters have decided that whenever we get an object, we'll break it up in a certain way, and then create and put it in serial locations in memory. And then whenever you have to reconstruct, we will use the same method to reconstruct it. So it's a
Got it, sir.
protocol.
very rudimentary form of encryption, decryption, sir. कि मतलब Java नहीं decrypt कर पाएगा वापस से उस कोड को, Python नहीं कर पाएगा.
सर मतलब इसमें हम ये कह सकते हैं कि अगर हमने एक फाइल पाइथन के थ्रू बनाई है तो वो फाइल पाइथन में चलेगी, जावा में नहीं चल सकती.
या नहीं पाइथन में अगर हमने एक फाइल पाइथन में बनाई है और उसको हमने मेमोरी में पिकलिंग किया यूजिंग पाइथन, then I cannot reconstruct that file using Java as my means.
Exactly, sir. That is what.
Just
No,
like indexing.
No, it's
Basically,
not indexing. It is not indexing. It is not encryption. It is nothing of this. It is a protocol.
Fragmentation, defragmentation, I think.
It is a protocol for, suppose you are given a jigsaw puzzle, or you are given a human, suppose you are given a huge statue and you are asked to break it up and take it to some other place and reassemble it, right? So now when you are breaking it up, you need to cut each piece and put some of your, maybe you and the person who's going to reconstruct, you guys develop some protocol. I will start the numbering from the bottom, maybe I will start from the top, maybe I'll start from the left, maybe I'll start from the bottom, maybe I'll do some color code. So you guys have developed a protocol, because when you are transporting the statue which you have broken into pieces, you have to put them in successive boxes. Suppose you have to, so let me just show this. Suppose you have a statue, so let's call it like this. This is a statue. And you need to send it, and you have got boxes in which you can put pieces, right? And then somebody has to reassemble it. So you may say, I will put the left foot in the first box, and then the right foot in the second box, and the body in the third box, and the left arm in the fourth box, and like that. And then
just like a jigsaw puzzle.
Yeah, but this is the protocol of Python. But Java may have a different protocol. They may say, I will put the head first, and then so therefore, what you have pickled in Python, you cannot unpickle in Java. Does it make sense?
Yes, sir. Now it makes sense very much.
Yeah, okay. So as opposed to this scheme, there's another scheme called JSON. Anyone of you heard of JSON?
So you've mentioned it's a type of file during when you were teaching us about dictionary.
Yeah, it is like, yeah, JSON in Python, JSON is equivalent to a dictionary, right? But in real life, JSON is simply what shall I say? It is a key value pair. Key value pairs, which is a dictionary in Python. For example, suppose I have to call a website. So what I will do, I will give the URL of the website and then question mark, then I will say username, user equal to AG, password equal to something else. So what I have done, I am passing these parameters in the form of a key value pair, right? So now when I pass this to the, when I use an API, when we use APIs, we will do a few APIs if we get the chance. So I have to pass it the parameters in the form of key value pairs. And when these key values are transmitted over the net, they are transmitted in the form of a JSON, JavaScript object notation. So these are what? These are human readable as opposed to the pickling. So therefore, I could do a similar scheme that when I'm packing a man into a box, then yeah, I'm sorry. Am I audible? I got disconnected in between.
Yes, sir.
Yeah, but I cannot share my screen because I have been disabled. So I need to be allowed to share my screen. So whoever is the admin has to allow.
सर आपको जाना था आप जा
So okay.
है ना, तो कल
So
कर सकते हैं.
ठीक है, we can do it tomorrow, but ठीक है. So would anybody like to, somehow my power went off. So it's this second time this happened. So anybody would like to ask any questions, we can do it. Otherwise, we can stop over here. Somebody, I would maybe the journey so far. So starting from the beginning, so most of you guys are able to follow all the lectures or the sessions. Have you been able to download Jupyter Notebook? Have you been able to install it? Have you been able to download the HTML files and use them? I just wanted to understand from you guys if it is there, then fine.
You, sir, could you join back?
Let me see. Can I join now? No, but I cannot share my screen. That is not And I think Balaji, the host, is probably is not there. Only
Sir, I'm back here. I was taking dinner because I'm in Bombay and in Naval headquarters actually. So they have discipline to take the food on time.
okay, you there. So, are you able to? Do you want me to continue or do you want me to stop here? Because we are not.
So
been
you can
able to-
continue if the machine is okay. You can continue, no problem. If you want
No,
for
but
next 20 minutes.
yeah, I can continue, but I cannot share my screen. That permission is not there.
Oh, then just leave it, sir. We can do it tomorrow. No problem.
All right, then. So, okay, then I think let's stop over here and we can do the rest tomorrow. We have covered most of the chapter, I think, of this thing. Somehow this chapter is taken 2 days and still not able to finish. All right, then. Okay, good night, everybody. All right.
Good night, sir.